Hi everyone, this is Mr. Cure. In this video, we're going to be looking at the normal force and how it can change, and it's not always equal to gravity. So what I have here is I've got a motionless book. What does that mean? Well, it means the book is not moving and the acceleration is zero, and the overall forces must be balanced. So the sum of the forces must be zero as well. So if the book had a mass of, or a weight of 15 newtons of gravity acting on it, the normal or surface force must be 15 newtons but in the opposite direction. And the reason is, again, because the acceleration is zero and the sum of the forces acting on the book must be zero. So the two forces are balanced. Hey, what happens now if I change things up? What would happen to the book if I push down? Remember, if I'm pushing down on the book, it's still not motionless. It's still motionless. So the acceleration has to be zero. And that must mean that all the forces have to add up to zero as well. Well, let's look at all the forces acting on the book. We're going to start with force of gravity. So force of gravity is going to be 15 newtons. But wait a second, I'm also going to be pulling downwards or pushing downwards at 10 newtons. So I'm going to have two forces. So I have my applied force over here, and it's also downwards. So what's going to happen? Well, my normal force must change. It must be larger in order to accommodate the downward force. So by pushing downwards on the book, I change the normal force. How big is the normal force? Well, here's a little trick we can use. I know that the sum of the forces must be zero, and the forces all have to equal zero, and they're going to be normal force, the applied force, and my force of gravity. So here, let's do this. I know my normal force is unknown. I leave it as Fn. I know my applied force is 10 newtons downwards. Gravity is 15 newtons downwards. And you see what we can do now? We can add these two together. They become negative 25, bring them over, and they become positive 25 newtons. Now, I already know that you knew that, but this is just a mathematical trick to show the actual size of forces. And you have to use this approach in the future. So here, the normal force is 25 newtons. Again, the reason it's taking into account the force of gravity and the applied force. So this is a great example where the normal force is not equal to gravity. So look out for situations like this. Well, what would happen if I had this? What if I pulled upwards with 10 newtons? The book is still motionless though. How's that possible? Well, let's look at the forces acting on us or on the book. So remember, I have gravity. It is going to be 15 newtons downwards. And then I have my applied force, which is now upwards at 10 newtons. I'm also going to have some kind of normal force. How big is it? Well, let's look at the situation. So again, my book is motionless, so the acceleration is zero, and the overall sum of the forces is going to be zero. So what does that mean? Well, the overall sum of the forces is going to equal the normal, the applied force, and the force of gravity. Well, what are they? Well, the normal force I don't know. The applied force is upwards now. Gravity is still downwards. So when I add these two together, we end up with -5. You bring it over, the normal force is going to be 5 newtons. And it makes sense because these two forces together must add up to 15 to counteract the force of gravity. So that's a great example. Again, another situation where the normal force is not equal to gravity. So again, be careful for these vertical situations. Here's another crazy example. What if I took the book and I stood on a stool and I pushed it up against the ceiling with a force of 45 newtons? I want to know what the heck is the normal force acting on this book. And you're like, what the heck are you talking about? Well, let's draw a diagram to represent the book. I know the book is not moving if I'm pushing it against the surface of the ceiling. So the acceleration is zero, and the sum of the forces is also going to be zero. Everything has to cancel. So now you got to figure out the forces acting on the book. Let's draw a free body diagram. So the free body diagram for the book, we're going to have our force of gravity. Remember, it's going to be 15 newtons downwards. It's still there, even though if I'm holding the book up. Now I'm applying a force upwards of 45 newtons. Well, wait a second. Which way is the normal force going to be? Well, remember, the normal force is perpendicular to the surface. What's the surface? Right there. So it's going to be acting downwards. So I'm going to have a downwards normal force. How big is the normal force? Well, let's use our mathematical approach to find out. I know the overall forces have to be zero. They're all balanced. And they are going to involve the applied force, gravity, and the normal force. So let's see what happens here. I know my applied force is upwards. Force of gravity is downwards, right? And I have my force normal. So when I add these two together, something interesting happens, right? So what happens is this becomes positive 30, and then my normal force becomes negative 30. So here, my normal force, believe it or not, is acting downwards. And again, it makes sense because these two forces together have to add up to 45 to counteract the force applied. So that's it. I just want to make sure you understood that the normal force is not equal to gravity. And be very careful when you're dealing with vertical forces in addition to gravity. And so you want to make sure that you can calculate what the actual surface or normal force is. That's it.